Okay, in video 3.1c, we will be looking at Hawkes problems from the section 3.1a. So please notice that the video names are not necessarily the same as the Hawkes names. And the reason for that is because I usually have more videos for a Hawkes section than I have just that section. Okay, let's take a look at some of these problems from Hawkes. Here's the first one, and I know these are going to be a little bit small, but I'm going to assume you can read those okay, and I'm going to draw a line to clearly indicate we have a left side and a right side. Let's take a look at the instructions to this problem, and I noticed in 3.1a all of the instructions are the same. They asked us to solve a linear equation. Okay, we're not surprised by that. And they want us to write our solution in integer. Remember what an integer is? Those nice numbers, -5, -2, 0, 1, 7, those nice numbers that we find on a number line, or as a simplified fraction, and I'm going to underline the word simplified, or as a decimal. Okay, let's take a look at this first problem. So the first step, clean up. So we take a look at each side separately and see if we can do anything to simplify that. So on the left, yeah, we can. Those are both numbers, those are like terms, so we can simplify that to be a -8.7. And on the right, well, good, we've got two variable terms that we can combine to give us give us 1, I'll get there, 1 in 9.7. Now I'm going to say, okay, that 1 in, I'm just going to rewrite this as just n plus 9.7, -8.7. So we haven't changed anything from here to here. I just rewrote 1 in as n. So it looks like we're going to have our variables on the right and our plain old numbers on the left. So the n is the only variable term we see, so he can stay there. We don't have to do anything with him. But who is out of place? Yes, the 9.7, which is on the right. We don't want any numbers on there, so we have to look and see what's being done to that 9.7 and then do the opposite. So I'm doing a few adjustments here. So how do we get rid of that 9.7 on the right? Well, since it's being added, we can subtract it, and we know if we subtract it on this side, we have to subtract on that side. And then take a look at the results once we do that. Ooh, good. We've got an all by itself on the right, and on the left, when we combine those two negative numbers, we would get -18.4. And once we get in all by itself, isolated, we can just turn that around if it's on the right and rewrite with that variable on the left. Okay, next problem. Easy problem. What are we going to do? Yeah, we're going to subtract 2 from both sides, and we would get 6 equals v. And you know the rest of the story. Turn that baby around, v equals 6. I included that one even though it's so easy to show you. There are some easy ones in this section in Hawkes. Okay, and then we've got one that looks like this, more decimals. And let's draw our line since there's a little bit more there to it. I'm going to try to be it here. I'm bad. Okay, what do you think of that? Okay, here's a big one. Alright, so this one's just a little bit bigger than the others, I mean in terms of font size. So in this one, I just don't want you to freak out when you see fractions. It's no big deal. If you know how to solve x minus 7 equals 3, you know how to do this. So we just take a look at, well, let's take a look at what we would do. X minus 7 equals 3. We want x all by itself. The only thing that's in the way, that's 7. So what are we going to do to get rid of it? Add 7, and you would end up with x equals 10. So with the fractions, it's going to work exactly the same. What's in the way to having x all by itself? Well, that's what we're going towards, right? X equals. What's in the way? Well, that minus 7/2. To get rid of it, what do you think we should do? Okay, we do the opposite of what's being done to it. 7, so we're going to add 7/2 to this side, and the result on the left These cancel, they go to 0, so that just leaves us with an x. And on the right we get 10 halves, and we say, oh, that is not simplified. We can change that to 5. And I think that's it for Hawkes problems 3.1a. They're all very similar to the ones that we've just done here.